Hey guys, example 1, week 6. This is testing a claim about a difference of two proportions. So let's go ahead and get started. So to ensure that production lines are running correctly, an inspector at the factory selected a random sample of 477 M&Ms, milk chocolate candies, and counted 125 blue. Another inspector selected a random sample of 175 M&M peanut candies, of which 39 were blue. Does this data give convincing evidence that the alpha equals 0.01 significance level that the population proportion of M&Ms milk chocolate candies that are blue is greater than the population proportion of M&M peanut candies that are blue? So let's go ahead and start with our state. So what we know is the null hypothesis is always going to be the same thing. P1 minus P2 equals 0. Now, for the alternative hypothesis, this is where it gets a little persnickety because we actually need to figure out what is P1 and what is P2 in order to determine if it's going to be greater than, less than, or not equal to. So based on the problem, it says that milk chocolate candies come first. So what I want to do is I want to say that P1 is going to be the true proportion of M&Ms that are blue. I also want to say that P2 in that case is going to be the true proportion of peanut M&Ms that are blue. So now we have plain and we have peanut. So with the plain, it says that we want to know if the milk chocolate candies are greater than the population. So that means this is going to be greater than 0. So this is saying this is the big number, this is the small number. A big number minus a small number is greater than, well, it's going to be greater than 0. So let's go ahead and then state what we know. So we know that the sample size for the first set of data is 477. We know that the sample size for the second set of data is 175. So let's go ahead and do the first set of data because they're all kind of in a line. The sample proportion P hat sub 1 is equal to 125 over 477. As a decimal, that's about 0.262. That's a little bit of rounding. The next one, P hat sub 2, that's going to be 39 over 175. If you put that as a decimal, it rounds to approximately 0.223. We know that our alpha level is 0.01. And now we need to figure out what the P hat sub C is. So this is that new part, P hat sub C. So I'm actually going to do that. We're going to put the total over here. So P hat sub C is going to be equal to all the blues over total number of M&Ms surveyed. So what that means is the total number of blue. So we had 125 and 39. So that is going to be our numerator. So that is 125 plus 39, and that's going to give us the total number of blue M&Ms. Now on the bottom, we're going to have the total number of all M&Ms. So we had our first sample size was 477 and our second one was 175. So we're going to add those two numbers on the bottom. So 477 plus 175. That's going to be our denominator. So our combined proportion, if we were to combine the proportions together, would give us 164 over 652, which would equal approximately 0.252. So that's 164 over 652, which is approximately 0.252. So this right here is 0.252. Okay, so now let's go ahead and move on to the plan stage. So in the plan stage, the first thing is the data random? And the answer is yes. Yes, it is. Then we have to check the first set of data. So n1 times p hat sub 1 has to be greater than or equal to 10. In this case, we have 477. I'm going to leave this as a fraction, times 125 over 477. Greater than or equal to 10, so is 125 greater than or equal to 10? Yes. The next one is going to be n1 times 1 minus p hat sub 1. So we have 477 times 1 minus 125 over 477 greater than or equal to 10, and that is 352. So yes, that is greater than or equal to 10. The next one is going to be n2 p hat sub 2. Is that greater than or equal to 10? So we have 175 times 39 over 175. Is that greater than or equal to 10? Yes. So 39 is greater than or equal to 10. Then we have n sub 2 times 1 minus p hat sub 2 greater than or equal to 10, and that gives us 136. And that is indeed greater than or equal to 10, so that's good. So then we know that it is normal by the large counts condition. We also can go ahead and draw our curve based on the alternative hypothesis. So the alternative hypothesis is greater than, so that means we're shading off to the right side. Okay, so let's go ahead and jump into do with the correct color. So in the do, we're going to go ahead and do our formula. We're going to calculate z value, use table A to find the z score, and then use that to determine the p-value. So let's check this out. So let's go ahead and calculate z. So z is equal to p hat sub 1 minus p hat sub 2 minus the null hypothesis, which is 0, divided by the square root of p hat sub c times 1 minus p hat sub c divided by n sub 1 plus p hat sub c times 1 minus p hat sub c divided by n sub 2. So I'm going to go ahead and fill these in, and then after they're filled in, I'm going to come back. So if you want to pause it and see if you can get the right numbers, go for it. Okay, so here are my numbers. I have p sub 1 minus p sub 2 divided by all that super fun stuff. Notice that everything is still underneath these square roots, so that way whenever we type it into Desmos, it's quite simple to do. We start with a fraction. So 0.262 minus 0.223 minus 0, which doesn't change anything, divided by the square root of a fraction, 0.252 times 1 minus 0.252 over 477 plus another fraction, 0.252 times 1 minus 0.252 divided by that sample size, which is 175, and you get 1.0164. I'm going to put that as 1.02. 1.02. So now what we have to do with that is we have to go into table A and figure out what the z-score is. So 1.02. So 1.0, this is table A, 0.02, go down, go over, and you get 0.8461. 0.8461. And then we have to determine the p-value. So if you go back and look at our curve, it's shaded to the right. From our notes, remember we said that if it is shaded to the right, the p-value is 1 minus the z-score. So your p-value is going to be equal to 1 minus 0.8461, which equals 0.1539. And then we have to conclude. We're going to compare our p-value to alpha. So in this situation, our p-value is 0.1539, and the alpha from the very beginning was 0.01. So we need to figure out, is the p-value greater than or less than? And in this case, it is indeed greater than. So because it is greater than, we are going to say that we fail to reject the null hypothesis because we have no evidence for the alternative. So let's go ahead and type that up. So we fail to reject the null hypothesis. We have no convincing evidence that there are more blue plain M&Ms than blue peanut M&Ms. So this is what we're going to write for our conclusion. We've done all of our steps, and so we are done with the problems. In the next video, we're going to talk about how to get all of this information from the beginning from a two-way table, and we're going to do that with another example. So see you in the next video.